Hi everybody, I am Gladden Gazalba, studying in Sri Venkateshwara College of Engineering, Bangalore, and I belong to Devas section, semester 1, roll number 23CA1978. Today, I'm going to talk about Introduction to Superconductors, Temperature Dependence of Resistivity, mentioning the critical temperature, subject code BPHYS 102. Introduction to superconductors. Superconductivity is a set of physical properties observed in certain materials where electrical resistance vanishes and magnetic fields are expelled from the material. Any material exhibiting these properties is a superconductor. A superconductor is a material that attains superconductivity, a state of matter with no electrical resistance. In a superconductor, an electric current can persist indefinitely. Superconducting materials. These are some examples of superconducting materials. Example: mercury, ceramic, lead, titanium, aluminium, copper oxide are some examples of superconducting materials. Temperature dependence of resistivity, mentioning the critical temperature. The materials with zero resistance are called superconductors. The temperatures at which the resistance drops to zero is called the critical temperature. High temperature, high magnetic field, and high current density will lose the property of superconductivity of a material. Mercury is an example for superconductor. Resistivity is indirectly proportional to the temperature. As there is an increase in the temperature of materials, their resistivities will decrease, but this is not true for every materials. That is, all materials do not have the same dependence on temperature. In a superconductor, below a temperature called the critical temperature, the electric resistance very suddenly falls to zero. At zero resistance, the material conductors current perfectly. The temperature has the inverse relationship with resistivity. In addition, as the temperature of materials rises, their resistivities fall. As the temperature rises, more electrons will be able to jump from the conductor band to the valence band, increasing the semiconductor's conductivity. When the superconductor is placed in the magnetic field, the magnetic field bends around the materials as it does not allow the magnetic field to pass through them. When the intensity of the magnetic field is increased at a certain point, the field is able to penetrate through the superconductor and thus its behavior is destroyed. Considering an electric current is passed through the superconductor, suppose the density of the current is increased at a particular value of current density. It loses its superconductivity and finally behave like a normal material. The current density above which the material loses its superconductivity is called the critical current density. High temperature, high magnetic field. Here, the graph represents the conductivity, conductors, semiconductors, insulator. The resistivities of metallic conductor within a limit range of temperatures are given by the following equation. Pt is equal to P0 1 plus A T minus T0. Here, Pt is equal to resistivity at a temperature T PO is equal to resistivity at a reference temperature 2A. Temperature of coefficient of resistivity. The dimension of is temperature. According to the above equation, a graph of Pt plotted against T would be a straight line. That is, the resistivity of a metallic conductor increases with increasing temperature. According to the general rule, the dependence of resistance on temperature is that the resistance increasing as the temperature increases in conductors and decreases with the increasing temperatures in insulators. Thank you for watching the video.